email you, see if I can log on through the computer. For whatever reason, it's bummed out.
Yeah.
So I want to try with someone who has like a hangout and see if I can do it when I'm not, pressed for time, or I don't
Yeah.
have to rush. So maybe like on Thursday night, or what day would be good just to try the computer and see if I can log in through the computer.
Um, I don't know.
Or I can wait till Saturday.
Trying to think about my week. And you said you're more free on Wednesdays, right?
Yeah, Wednesday mornings I'm good with anything. Um, and Thursday mornings I'm good, and Wednesday afternoons it's fine too. All day Wednesday's fine.
Okay. Yeah, tomorrow I am done at 11:30, so we can like work together and stuff on some stuff.
Okay.
So yeah, I'll be well, that would be 10:30 your time, but
Okay.
okay. Yeah, I think I'm good on all the homework because you just had to pick those random five numbers, which will
Yeah.
take forever because I'm sure we picked different numbers. But it was pretty simple, I think.
Yeah.
And then
So
number
the
8 was super easy. It just all depended on the parent population, and the parent population was normal, so it made number 8 really easy.
so I've got the quiz open, and
All right, I'll open it up too. Okay. Don't forget the first two questions
no,
this
I
time,
know,
Alma.
I know I emailed her the following day. So the question says, it says when taking a sample of n, when n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed? Is it right skewed, normal skewed, skewed left?
I think it's right skewed because usually a sample size that's like relatively small, doesn't it just follow the parent population
It does. I'm
distribution?
looking.
Let me look at my notes real quick.
It says a standard deviation of 2. This distribution is skewed to the right. So anything that I think that's 10 and less, no. But yeah, the smaller the sample, the skewed to the right it is.
So we're thinking it's skewed to the right.
Mm-hmm.
Okay. All right. Okay, when taking samples of size 100, what was the shape of the distribution of means histogram when the parent population is right skewed? Um, so I have in my notes that says if the parent population is heavily skewed,
Mm-hmm.
um, then as long as n is about 30 or more, it's a normal distribution. But I don't know.
I'm looking at my notes and it says suppose a random sample of 100 students were surveying concerning the internet usage. Sample of 100 would be considered a large sample. What is the mean standard deviation and shape of the distribution of the mean number of college credits that a student has taken by the time he or she is intro into a statistics class? All I have, it says normal or bell shaped.
I think it's normal because the sample size is so large. And in the notes it said like if sample was really, really large, it makes it a normal distribution, even if the parent population isn't normal.
How would that change from like 4 and then to 5? Because 5 is actually the same question above, with the exception that the ending of the question says the parent population is normally distributed.
Then it would just be normal.
Okay.
I'm pretty sure because like it's normal. So there's only like weird exceptions if it's not normal. If it is normal, then the distribution's still normal.
Okay. It
All
says
right.
number 6 says when would the distribution means be normally distributed? I think when it's a larger size. Um,
Mm-hmm.
it says data are drawn from population that is normally distributed and the sample size is large. I would say it'd be the second one.
Okay. It's definitely the last one too. Data are drawn from a population that is right skewed and the sample size is large. Because if your sample size is large enough, even if the population is skewed, the distribution will still be normal.
So you're saying it's 4?
Yeah, it's that last one too.
So it'd be
I think it might be the first one too. Because I think it might be the first one too. If the population is normal, then the distribution is going to be normal no matter what.
Let me look.
You know? I guess I don't think it would matter on the sample size.
Let me just make sure. It says, according to what I have here, it says the shape, it says as the sample size n increases and becomes large, the distribution of sample means becomes approximately normal. And then it says, if the mean of the original population is, then the mean of the distribution sample mean is, I forget what the squiggly line means.
It's just like about, I don't know, maybe, I don't know what squiggly line you mean.
So you're saying it's 1, 2, and 4?
I don't know if it's definitely 2 and 4. I'm just a little confused about 1.
It says, regardless of the sample size, the shape of the distribution of the sample means is normal. I'm confusing myself, I think.
I think it might be 1 because I remember reading that if the parent population is normal, then the distribution is going to be normal no matter what. And
So
if it's not normal, that's when the sample size matters.
Okay.
I'm pretty sure that's right.
So you're saying it's number 1 through 2 and 4 for all correct responses. Okay.
Well, let's hope so. Let's
Yeah.
find out. All right. Which of the following gives the best explanation of the central limit theorem? If the parent population from which the data are drawn is normally distributed, then the sample mean X bar will follow a normal distribution. For bell-shaped data, approximately 68% of the data will be within one standard deviation of the mean, about 90. Oh, that's not it. That's talking about the. If the sample size is large, the sample mean X bar will be close to the population mean U, which I think is right. And then the last one is if the sample size is large, the shape of the sampling distribution of the sample mean X bar will be approximately normal.
I think it's that one.
Okay, let me read the definition. Okay, so the definition, the central limit theorem. I'm thinking of large numbers. Okay, central limit theorem says if the sample size is large, the random variable X bar will be approximately normally distributed. So it is the last one, yeah. I was thinking of law of large numbers.
Okay.
All right.
The law of large numbers? Oh, yeah.
I was getting those confused.
I get lots of things confused. It says let X be the random variable with population mean equal 10 and population standard deviation equals 6. Suppose the sample size equals 36 is drawn from this population. What is the mean of the distribution of the sample size? Okay. So this takes a little calculation.
Yeah.
Let me grab my paper and pen. Diego, did you take my pencil? Okay. So means is equal to means of parent population. So would we take the to figure it out, we would take the square root of the population. Hello?
But we don't have the population. I have no idea how to solve this.
Oh.
Because we have the mean and we have the standard deviation of the population and we have the sample size. I don't know how to solve it. I don't remember reading about this. Probably missed it somewhere.
So number 8 and 9 are together.
Yeah.
What is the standard deviation of the distribution sample means?
Oh, I can pull up the reading real quick.
Let me go back on there. I thought it was the formula that we used where it says the means of the distribution of sample mean equals the mean of the parent population.
Yeah, so that would just equal 10, right? Because the mean is 10.
Yeah.
Okay, so then the standard deviation is that one thing where you have to take the standard deviation of the parent population and divide it by the square root of n.
Uh-huh.
Okay.
And n is 36, though.
Yeah, so you would just take the square root of 36, which is 6. And then 6 divided by 6 is just 1. So it would just...
The mean, which is 10... Or the standard deviation would be 10?
No, the standard deviation would just 6. Be 1, I think.
So when it has a standard deviation and then the x at the bottom or at the side, you know how in the parentheses it has like this little formula that has a parentheses and it says the standard deviation and then has an x equals the standard deviation divided by the square root of n?
Yeah.
What does the x stand for? Oh, that stands for the mean.
I think so.
Yes, honey. So 1 equals... Let me look up the book. What I can't figure out, I know on the right side it's 1, but I don't know what the standard deviation with the mean, what does that become?
I don't think we use the mean at all when we're trying to find the standard deviation for sample means.
But you know how in the formula, if you go to your notes under let me go what I'm looking at. If you were to open the introductory, let's see if it's there. No. Under resources, under the course, you can go ahead and not resources. Where is it? Where is it? Oh, under references. Is it under references? No. There's a place where you can go and print out exactly what the PowerPoint presentation is. Let me see if I can find. Oh, lesson PowerPoints.
All right. Can you? Hold on, my internet isn't loading. Can you, like, if you go on our screen that we're talking on right now, and you go over to the right side of it, I mean the left side of it, there's a button that says screen share.
On the left side of my phone?
Oh, it might not be on your phone. Okay. And my internet is being really slow. It will not pull up the school page. So I can't even go to my read references.
I hate that when that happens.
Yeah, but you're already on the internet, so you're like,
Let me see if I can. Normal distribution. Let me see if I can go ahead and at least have you see what I'm seeing somehow.
okay.
I'm just going to open it up.
Yeah, I
No, it's
don't know
not
why it's
that
loading
one.
so slow.
And you're in Idaho, right?
Yeah.
Do you live on campus?
Yeah, I do.
Oh, that's cool. Why can't I find it? Are you originally from Idaho? No.
No, I'm from Colorado.
Oh, wow.
Yeah, I'm here until April.
Is that when you graduate?
No, this is only my second year, so it's when I finish my second year. I'm excited for that.
So, okay, so I don't know if you can see this. Oops. Can you see that or not?
No, I see a water bottle and a chair.
Oh.
Oh, there you go.
So see that formula, that mean and then the standard deviation.
Oh, okay. I see what you mean. It's
I don't
just saying
know.
that the standard deviation of the mean.
Okay.
So it's just saying like this, what's the standard deviation of 10? So
So
10
then
doesn't even play a role in it. It's just asking what the standard deviation
it
is.
must just be 1 then.
I think so. And it says 3 decimal places. So I'm thinking we just put
1.00.
1.0000.
That's the only thing that I can think of. I don't see any other.
Yeah, but I just feel like it's weird if she asked for decimal places. You
It
know?
is weird.
I don't know. Well, let's
But
hope that's
in
right.
the answer it doesn't in number 8 it doesn't say you know how in parentheses sometimes it'll say, round to the 3 decimals behind?
Yeah.
It doesn't say that.
Yeah, that is true.
I'm just going to put 1.
All right, number 10 says,
Oh, but number 9 does.
yeah,
So what was number 8 then?
10 because it's the same as the population mean.
Okay. Okay, so 10 says, regardless of the distribution of the population, if a sample size is larger than 30, what would the shape distribution of the sample mean be?
It would be normal.
Normal.
Yeah. All right, and then 11 says, what theorem would justify a response to question 10? It's the central limit one, because
Yeah.
that one says it'll be normal.
Yeah.
Let's see.
I always hold my breath.
Oh, hey, we got 100.
Oh, yay.
So I guess 1 was right.
That was such a weird question, wasn't it?
Yeah, it was. Oh, okay, that was cool.
Yeah.
I think that was like our first 100.
I know, huh? Did she ever answer that question about I emailed her that one question that we missed on the previous quiz?
I don't remember what let me look.
That one seems so long ago, but oh, she said it was 0.35 and we got
0.35.
0.38.
Ah, that is so close.
Yeah.
That's irritating.
Yeah. It says, it looks like you missed number 17 for this problem. You first entered 0.35 into the APULET and you get negative 0.385. Then you enter this value and the other values into the Z formula. Doing so, you get negative 0.385.
Mm.
And then the final answer would be 0.633. I think we had 0.689 or 0 point something. Anyhow, we missed it.
That's okay.
Yeah. So I'm going to try tomorrow at around 10:30 just to see if I can log on to the computer. It'll make things much easier than me trying to do this by phone.
Yeah. Okay.
But, okay?
Yeah. Yeah, I should be home right around 10:30 your time, 10:45-ish.
Okay.
I'll just email you on Hangouts to let you know when I'm going to be home.
Okay.
And then we can try.
All right. And then just let me
All right.
know if and when she decides to, put us in another group.
Okay, I will.
Thank you.
Yeah.
You have a good night.
You too. Bye.
Bye.